Welcome back everyone, this is Ishan and you are watching Programming with Ishan. Today you are in the second part of chapter 2 of our Angular course, and up until now we have discussed some of the essential foundational concepts like differences between MPA versus SPA. We also talked about the architectural pattern in our last part and also discussed about the differences between MVC and MVVM architecture. Now in this part we will try to dive deeper into the core of our Angular framework, wherein we will be trying to discuss the core building blocks of our Angular. We will also try to discuss the change detection mechanism as well as the binding mechanism of Angular and how it works. And finally, we will be discussing about the file structure of the Angular project, which we created in our first chapter. Also, this is very important for you guys to know that Angular has undergone some of the exciting changes in the recent versions of Angular, specifically starting from Angular 16, wherein they have created this new architecture which uses standalone components. In the traditional architecture, it was using ng modules, and it is widely used and creates a backbone for so many of the projects being created in Angular. For this course, we will be focusing on the traditional approach of the Angular architecture itself to create solid applications. If you are curious about the newer architecture, you don't need to worry. I will be covering that in detail in my upcoming course on Angular 18. But for now, let's get started and unravel the next layer of Angular together. Have you ever wondered what actually makes Angular one of the most powerful framework to create a web application? It's not just the tools, it's actually the foundational building blocks that Angular comes with to create and hold everything together. And trust me, these are not just the concepts, these are actually the blueprints which helps to create an application that is maintainable, scalable, as well as efficient. Throughout this course, we will be exploring the building blocks like modules, components, templates, services and dependency injections, directives, pipes, routing, metadata, as well as observable in RxJS in one or the other way. Each of these play a vital role, and together they make the foundation of every single Angular application. Now let's try to dive deeper into this and understand how exactly these building blocks are interrelated with each other by comparing them with a real-world example. I think we can understand the core building blocks of Angular with an example of a restaurant. So let's consider a restaurant whose name is Angular application, and this restaurant is having a manager appointed. Let's keep the name of this manager as Mr. App Module. Okay. Now, Mr. App Module is responsible for managing and coordinating everything going on in the restaurant, like from overseeing all the departments of that restaurant to ensuring that the rules, services, and conditions that are required for the proper functioning of the restaurant should be in place. We talked about the departments. So generally, most of the restaurants will have multiple departments. We also have 3 of them. Let's say we have a kitchen department, a dining department, as well as a billing department. Each of these departments are having specific tasks and responsibilities assigned to them, but at the end, they will still report back to Mr. App Module itself. Now, by that logic, we can call Mr. App Module is behaving as the root of the complete working of the restaurant. So we can also call Mr. App Module as Mr. Root Module. Okay. So this is about the relation between the manager and the departments of the restaurant. But we also need to understand how individually these departments are working. So each department is having so many segregations and subsets, right? So let's try to understand the working of one of these departments, considering kitchen department as our example. Kitchen department is generally responsible for organizing everything which is required for the kitchen to work and function properly. So in our example, let's say in our kitchen, we have 2 stations. One is a menu station and one is a recipe station. Menu station is responsible for providing the list of menus and the items required for preparing those menus to the kitchen staff. Okay. And the recipe station is responsible for providing the recipe cards to the kitchen staff so that they can prepare those menus properly. So now the next question comes up is who actually provides this data which needs to be available on the menu station and recipe station. So for that purpose, our restaurant manager, Mr. App Module, has also appointed a chef. Let's keep the name of the chef as Mr. Angular Services. And Mr. Angular Services is responsible for providing any sort of data required by the stations which we have in the kitchen, and also for any items which is required from outside the restaurant, like to buy some vegetables or any items related to the groceries, whatever is required by the kitchen staff to prepare the menu prepared by the chef. So that is all the job of Mr. Angular Services. So we can call him as the brain behind the kitchen working, right? Next thing comes that how exactly the kitchen staff will be able to get that data in a presentable manner. So for that purpose, our restaurant manager has also proposed a menu as well as a recipe card which can be provided to the kitchen staff, and that keeps updating whenever the data gets updated on the menu station and recipe station by the chef. Also, we have some directives and a menu formatter which is applied on the menu template for the purpose of formatting the data visible on the menu template, or else adding some rules or updating the list of items. So this is the job of the directive and the formatter. And finally, we have the routing. So routing can be presented in a kitchen department in such a way that if a staff wants to get the menu, so there's a different path in a kitchen which leads to the menu station, and if a staff wants to get the recipe card, there's a different path in the kitchen to reach the recipe path. So this is the part of the routing. So let's try to understand this relation better by switching few of the images and text with the relevant ones. Let's have this restaurant as the Angular application and the restaurant manager to be as the app module of this application, also considered as the entry point of the Angular application. Each department with the individual module. So our kitchen department becomes the kitchen module, dining department becomes the dining module, and so on. They are as a group termed as the feature modules of the Angular application. The stations which we created for our kitchen department to be switched with the components, the Angular components. So we will have menu component and the recipe component. The chef, Mr. Angular Services, let's switch him with the Angular service, which is responsible for bringing the data and passing it to the component. Also our supermarket to be as the backend application from where the Mr. Angular Services was taking some data, specifically the items which are required for preparing the food. Our templates, let them remain be templates because they are the presentable part. They are the HTML pages in our Angular application. Menu formatters will be replaced with the Angular pipes, and directives with the Angular directives. And finally, the routing part. So for the user to know how to reach to a certain component or a certain template, we have the routes defined. They help on the browser for redirecting a user to a certain page. Like if the user wants to reach the menu page, or if the user wants to reach the recipe page, this is how you define the separate routes for that. So this sums up the Angular core building blocks and their interconnections. In Angular, there are two core concepts, that is a data binding and a change detection. Now, data binding and change detection are the two magical concepts that are responsible for the connect between a template and a component. Data binding is something which Angular uses to connect the data from your component to the template and vice versa. Component, that is the code part, template, that is the HTML part of your framework. Let's see that with an example of the menu component and the menu template, which we saw in our previous slides. Let's say we have this code in the menu component which contains a message variable as well as a is button disabled variable. Message variable is initialized with a hello world value, and is button disabled is initialized with a false value. And we also have a change message method which is responsible for updating the value of the message variable and button disabled variable to true. Okay. Now in Angular, there are multiple ways to create bindings between the component and the template attached to that component. Let's say we have this code where we have a header tag, we have a button tag, and we have an input tag. You can see that in a header tag, we have the same message variable which we defined in our component attached. But the difference here is that the message variable is enclosed with a double curly braces. This double curly braces provides this binding which we call as an interpolation. So any value change happening in the component will get reflected on the template because of this interpolation. Second way of creating a binding between a component and a template is an event binding. So if you see in our example, we have a button tag with a click event that is enclosed within a parenthesis and attached to a method that is change message. So every time a user clicks on this button, the click event gets fired and the change message gets called. Also, if you see, we have this disabled property of the button that is enclosed within a square bracket is attached to the second variable of our component, that is button disabled. So now when the button was clicked, the change message got fired and the value of this dot message, if you can see in the above part, this dot message got changed to you clicked the button and the is button disabled value got updated to true. So these two value updates will be reflected on our button as well as on the header tag. Header tag because of interpolation, and on the button because of the third way of binding, that is your property binding. So any property enclosed within a square bracket is able to create a property binding with a variable coming from the component. Now the fourth part is the two-way data binding. Two-way data binding is a combination of an event binding and property binding. To create a two-way data binding, you have to use this keyword, that is ng model, inside a parenthesis which should be inside a square bracket. Any variable attached to this keyword will reflect the change in the value from template to the component and from component to the template, creating a two-way data binding. So this is all about the data binding part. Now we need to understand how this data binding is actually working. For bindings to work properly, Angular is dependent on the change detection mechanism. So let's look into that part. Change detection in Angular is a way of checking if something has changed in your app and ensuring your template reflects those changes. When you click the button, Angular's change detection mechanism notices the changes in message and updates the text in the browser. This process happens behind the scene for every user interaction or data updates. Now there are two strategies for performing change detection. One is the default and the other one is on-push strategy. Default strategy is kind of automatic checks which are happening for all the bindings that are created. But on-push is for the purpose of performance optimization, and it optimizes the performance by limiting checks to a specific input. So this is the difference between the default and the on-push. Now all these what we are talking about at this moment is for the synchronous operations where we don't need to wait for a response to occur. So when a user clicked on a button, the method got called and the message variable and the other variable got updated. So you did not need to wait for anything. But what if there is an async operation? So when a user clicked on the button, an API got called, an HTTP request was made to a backend to get the data from the backend. So for that case, the application needs to wait for that response to come and then update the template, right? Now Angular for that purpose is having a ng zone defined, which is backed up by zone.js. It's a third-party library which Angular uses for the purpose of asynchronous change detection. So we will not be going into the depth of this, but for you, this is more than enough at this point to understand that for any asynchronous change detection, we have zone.js in the Angular framework for the purpose to be satisfied. Thank you for watching this video, guys. If you really enjoyed this video, please don't forget to like, share and subscribe our channel for more updates. Also, in the third part of this chapter, we will be discussing about the file structure in depth, and we will be doing an analysis on the Angular features at the code level, and also we will be discussing about the metadata and decorators.